In this lesson, we're going to look at curvature and the principal unit tangent vector. To find the curvature, we use t, which is the unit tangent vector, s, which is the arc length, and k represents the curvature. To find the curvature, k, it is equal to the magnitude of the change in the unit tangent vector with respect to the change in arc length. Let's move that up. And a more simple formula to use is that the curvature is 1 over the magnitude of the velocity vector times the magnitude of the change in curvature with respect to the change in time. So we're going to use this formula to find the curvature. And this is the formula that we will use to find the curvature. In this example, we're going to find the curvature for the following planar curve, which is r of t. R of t is equal to 12t in the I direction plus 12 times the natural log of the cosine of t in the j direction, and t is going to be between negative pi over 2 and positive pi over 2. So we're going to start by finding the velocity vector, v, and we do that by finding the derivative of r of t with respect to t. The derivative of 12t is 12, so we have 12 in the I direction, plus the derivative of 12 times the natural log of the cosine of t, and this will require the chain rule. So we have 12, and the derivative of the natural log is 1 over the cosine of t, and the derivative of the cosine of t is the negative sine t, so we have a negative sine of t, and this is in the j direction. And of course we can simplify this to 12 in the I direction plus a negative 12 times the tangent of t in the j direction. And we'll take this and let's move this up here. This is our, and we're taking these separately. Looks like these are coming up separately here. There we go. So this is our velocity vector right here. So now we want to find the magnitude of the velocity, which is the square root of 12 squared plus a negative 12 tangent t squared. So that's equal to the square root of 144 plus 144 tangent squared t. And we can simplify that, but let's move that up. And when we simplify that, we get that the magnitude of the velocity, and what I'm going to do here is I'm going to factor out the 144, and the square root of 144 is 12, so that brings a 12 on the outside times the square root of 1 plus the tangent squared t And this is equal to 12 times the square root of the secant squared, t, which simplifies to 12 secant t. So let's move this up. And here we have the magnitude of the velocity. Next, we want to find the unit tangent vector. The unit tangent vector is the velocity divided by the magnitude of the velocity, and we've determined what both of those are, the numerator and the denominator. The numerator is above 12 in the I direction minus 12 tangent t in the j direction. And this is divided by the magnitude of t, and we can do each term separately, or each component separately. And the magnitude of the velocity is 12 secant t. And clearly we can see that the secants, or excuse me, the 12s will cancel out. So in the I direction, we have 1 over the secant, and the secant is 1 over cosine. So we have the cosine of t in the I direction minus, and now we have the tangent over the secant. The tangent is the sine over the cosine. The secant is 1 over the cosine, so this becomes the sine of t in the j direction. So let's take this and let's move this up, and we have the next piece we need for curvature, which is our unit tangent vector here. Okay, so we're going to need to move some of this up. Let's move up our velocity just to make some room on the bottom. Here's our velocity vector. Here's the magnitude of the velocity, and we simplify the magnitude velocity here, and then we'll move up our unit tangent vector. And what we want to do now is find the magnitude of the derivative of the unit tangent vector with respect to time. And that's going to be the magnitude of the derivative of the cosine is a negative sine, so sine of t in the I direction, minus the derivative of the sine is the cosine of t in the j direction. And to find the magnitude, we're going to take the square root of the negative sine of t, which is negative sine of t squared, so sine squared t, plus a negative cosine of t squared, which is cosine squared t. And that is the square root of 1, so this is equal to 1. So our magnitude, here we go, of the derivative of the unit tangent curve with respect to time is 1. So now we can find the curvature. The curvature is 1 over the magnitude of the velocity vector times the magnitude of the unit tangent vector, the derivative of the unit tangent vector with respect to time, and the magnitude of the velocity vector is 12 times the secant of t, and of course the magnitude of the derivative of the unit tangent vector with respect to time is 1. So we know that secant is 1 over cosine, so it becomes, the curvature is 1/12 times the cosine of t. So this is our curvature. Now we're going to look at finding the principal normal vector of r of t, and we call that n. At any point where the curvature is not equal to 0, we can find the normal vector. The normal vector, or the formula for the normal vector, is 1 over the curvature, 1 over k, the curvature, times the change in the unit tangent vector with respect to the change in arc length. So let's move that formula up. So a better way to calculate this is the following formula. The principal normal vector is the derivative of the unit tangent vector with respect to time over the magnitude of the derivative of the unit tangent vector with respect to time. Let's move that up. Actually, why don't we center these on the page here? This is the formula that we want right here. So this is the formula that we'll use to find the principal unit normal vector. So in our previous problem, we were looking at r of t, which was the curve, the planar curve, 12t in the I direction plus 12 times the natural log of the cosine of t in the j direction. And that was from negative pi over 2 to pi over 2. That's our restriction for t. And we found, let's move that up, we found the velocity. We found that the velocity vector, v of t, is equal to 12 in the I direction minus 12 tangent t in the j direction. So let's move that up. There's our velocity. And then we found that the magnitude of the velocity is equal to 12 times the secant of t. And let's move that up. Let's separate on us there. We also found the unit tangent vector of t to be equal to the cosine of t in the I direction minus the sine of t in the j direction. And we'll move that one up. And so what we're looking for here is the principal normal vector, which is the derivative of the unit tangent vector with respect to time over the magnitude of the derivative of the unit tangent vector with respect to time. So this is what we're looking for. And we'll move that up. Let's move that up there. So we need to find the derivative of the unit tangent vector with respect to time. So let's change our color. Well, we'll stay with black. The derivative of the unit tangent vector with respect to time is equal to, the derivative of the cosine is a negative sine, so we have a negative sine of t in the I direction, minus the derivative of the cosine of the sine is the cosine of t, and that's in the j direction. So that's the derivative. Let's move that up. That is the derivative of the unit tangent vector. And so now if we want to find the magnitude of the derivative of the unit tangent vector with respect to time, it's going to be the square root of the square of negative sine t, which is sine squared t, plus the square of the negative cosine of t, which is the cosine squared t. And that's going to be equal to 1. So we'll move that up. So since we know that our principal normal vector is the ratio of the derivative of the unit tangent vector with respect to the magnitude of the derivative of the unit tangent vector with respect to time, we get that the principal unit normal vector is a negative sine of t in the I direction minus the cosine of t in the j direction. So we'll put a box around this. So this is what we were looking for. The principal unit normal vector.